Hello, hello. So we have a few problems here solving quadratic equations. Everything from use the square root method like the first one to using the quadratic formula to an application problem. So I want to go through 6 problems with you. The first one says solve using the square root method. Now, when you use the square root method, the first thing I want you to realize is you have to have something squared on one side equals to a number on the other side. You can never have a variable on this number side. So we do have that. Our something squared is in parentheses, but you can totally use the square root property now. So what do? So I'm going to take the square root of this side, and I'm going to take the square root of this side. Is that allowed? Absolutely. But you must put a plus or minus in front of one of the sides. The side that you put the plus or minus in front of is the numerical side. So why did I do that? So let me rewrite what we have. We have the square root of 2s plus 1 squared is equal to plus or minus the square root of 1. Now what do? Well, you simplify. The reason we took the square root is so I can cancel this and this. Those are inverse operations of each other, so therefore a square root and a square, as long as the entire inside is squared, they cancel each other out. So on the left, I have 2s plus 1. Now on the right, 1 is a perfect square, so we know the square root of 1 is 1, so I have plus or minus. Again, I evaluate the square root of 1 and I get 1. Well, now what do? Well, you have 2 different questions here, or 2 different equations to solve. So I have 2s plus 1 is equal to negative 1, and I also have 2s plus 1 is equal to positive 1. So now is the time to split it into 2 separate problems. And now what we have are called linear equations. It's s to the first power, which is just an easy subtract 1 on both sides. Those cancel. That gives me 2s is equal to, now negative 1 minus 1 is negative 2. I divide both sides by 2 and get s is equal to negative 1. On the other hand, for the plus 1, I subtract 1 from both sides. That gives me 2s is equal to 1 minus 1 is 0. Divide both sides of the equation by 2. That gives me s is 0 divided by 2, which we know is 0. So I have 2 solutions to this equation, and that is using the square root method. Turns out every quadratic equation has 2 solutions. Sometimes, though, it's a little weird, like it's the same number both times. That's 2 solutions, but 1 unique number. Sometimes you don't get real valued answers, but you should always expect 2 solutions in case you have some weird stuff going on, which is still 2 solutions, just a little bit odd. Okay, so for our second problem, it says find all real solutions of the equation. Now, on the last problem, I mentioned you could have not real solutions, okay? That's if you find yourself taking the square root of a negative number. So anytime you take the square root of a negative number, then you don't have any real solutions, or you don't have a real solutions in that particular problem. But this one, once again, we could use the square root property because we have something squared equals a number. Yet, we've got this 6 in front that's a problem. So to remove that 6, I'm going to divide both sides by 6. Why divide? Because I'm multiplying. That's 6 times a squared. And to undo multiplication, you divide. Now, what does that give me? X squared is equal to 24 divided by 6, we know is 4. So notice, just like the last problem, we have something squared equals a number. So the next step would be to take the square root of both sides. So I have the square root of a squared is equal to the square root of 4. But now again, you're not allowed just to throw a square root in on your own. You need to put plus or minus in front of the numerical side, the number side, okay? Now, on the left, though, the square root and the square cancel each other out. So what I'm left with is a equals plus or minus. Now the square root of 4 we know is 2. Now once you get the plus or minus, you separate that into 2 problems. The left equal to negative 2 and the left equal to positive 2. So a is equal to negative 2 and a is equal to positive 2. And the real word I should say there in between is or, because your solution is a equals negative 2 or a equals positive 2. Now this one is a little easier than the last one because we don't have to solve for a anymore. It's already isolated. And there are my two real valued solutions. Because I didn't take the square root of a negative number, therefore I don't have any non-real solutions. Now for our third problem, so let's investigate what we got. So again, notice we've got something squared equals a number. But then we've got all this extra stuff going on, like a -4 and a times 7. Well, you know what we could do? We could isolate, in other words, get the square part by itself on one side, and make sure we don't have any variables on the other side. And if that's the case, then once again we could use the square root property. So the first thing I'm going to do is add 4 to both sides of my equation so we can remove that -4. Of course those cancel, right? You have 7 times 5x minus 4 squared is equal to 112. Now my next step is to get rid of that 7 because I want just the square thing on one side by itself. So I'm going to divide this side by 7 because that's multiplication, and divide the right side by 7. So that gives me 5x minus 4 squared is equal to, now does 112 divide by 7? Pulling out my calculator to see. So 112 divided by 7, that's convenient, it's 16. Okay, so notice what you have. You have something squared equals a number. So once again, I'm allowed to use the square root property. So I take the square root of the left side, which is 5x minus 4 squared, and I take the square root of the right side as well. But I'm not allowed to throw a square root into a problem unless I put the plus or minus. So there's my plus or minus. Now remember what happens next. The square root and the square cancel each other out. So I'm left with 5x minus 4 is equal to plus or minus 4. Now my next step, I'm trying to solve for x. But listen, you can't do that with the plus or minus over here. So we split it up into two separate problems. 5x minus 4 equals -4. And also 5x minus 4 is equal to positive 4. So when I solve the equation on the left, I add 4 to both sides of my equation. I get 5x is equal to 0, divide both sides by 5, and I get x is equal to 0 divided by 5, which we know is 0. Trying to solve for x in the second equation, so I add 4 and add 4, but this time I get 5x is equal to 8. I divide both sides by 5, and I get x is equal to 8/5. And there are my expected two solutions. Either my answer is x equals 0 or my answer is x equals 8/5. Both of those, if you plugged them back into the original equation, would give you a solution. In other words, the left and the right match. Now, our fourth problem here is a little different. It says to solve. It doesn't tell you what method to use. And at first sight, you can't even tell that this is a quadratic equation. But we know that it is because if we multiplied the right-hand side of the equation out, in other words, a times a times 1, -6 times a, -6 times 1, and FOILed that out, we would have an a squared. Anytime your highest exponent for your variable is a 2, it's squared, you have a quadratic equation. And the idea for quadratic equations, if you can't use the square root property, and you cannot on this one, and I'll explain why shortly, you have to get it equal to 0. Look, there's a -10 over here. Okay, so what I need to do is I need to, often that's called FOIL, I need to multiply that out. So it gives me -10 equals, we know a times a is a squared, a times 1 is plus 1a, -6 times a is -6a, and -6 times 1 is -6. So now I clearly see I have an a squared as my highest power. So my goal next is to simplify each side completely. Those two like terms add together. So I get a squared minus 5a minus 6. But now, to do anything with this, I need to get it equal to 0. And then you might ask yourself, well, what about that square root property we just learned? Well, you know what? I have something squared here but I also have this extra a to the first power term. Anytime you have that in your quadratic equation, you can't use the square root property. Okay, so we need to just get this equal to 0. I'm going to add 10 to both sides of my equation. Why? Oh, my window's moving. So I'm adding 10 to both sides of my equation. I got my window straightened out. 0 equals a squared minus 5a, negative 6 plus 10 is plus 4. Now you've got options, okay? So the question is, do you want to factor this problem, or do you want to use the quadratic formula? Now the good news is the quadratic formula works for every single type of quadratic equation as long as it's in this standard form. Okay, factoring only works for quadratic equations that factor, but this does factor because we're trying to find numbers that multiply to be the constant, which is 4, but they also add to be the x coefficient, or in this case the a coefficient, which is negative 5, and numbers that do that are negative 4 and negative 1, right? So this does factor. How? That's going to be a minus 4 times a minus 1. How could you check yourself? Well, a times a is a squared. A times negative 1 is negative a, minus 4a gives me negative 5a, and negative 4 times negative 1 is 4. Yes, it's right. So now what do? Well, whenever you have a quadratic equation that's factored and it's equal to 0, then you separately set each of these factors equal to 0. So I add 4 to both sides and I get a equals 4. Or I add 1 to both sides and get a equals 1, and those are my two solutions. Now back to the beginning, a lot of people try to say a minus 6 equals negative 10 and a plus 1 equals negative 10, but that's not true. Again, you have to have a 0 to do the step of setting each one equal to 0, because when you multiply two numbers together and it gives you 0, you know one of them is 0, whereas not the case when you're dealing with negative 10. All right, next problem. Now we have specific directions here that says solve using the quadratic formula. Well, you can only use the quadratic formula on quadratic equations. Is this quadratic? Sure is, because of the x squared. Or quadratic type equations, which is a different conversation, but you could use the quadratic formula there. But here's the thing. To use the quadratic formula, let's write it down. X is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. All right, now, to determine what is a, what b is, and what c is, your quadratic equation must be equal to 0. Ours isn't, right? We have something equal to 7. So let's subtract 7 from both sides of the equation. So I have 6x squared minus 6x minus 7 equals 0, right? There's no like terms here, so I just have to write minus 7 equals 0. Now, you need to recognize what is a, what is b, what is c, and what this is called standard form of a quadratic equation. Well, look, a is 6, b is negative 6, notice you take the sign with it, and c is negative 7. You will never, ever have variables in your a, b, and c. So again, a is 6, b is negative 6, c is negative 7. No variables. Now what do I do with that? I plug it directly into the quadratic formula. So it says x equals negative b. So negative, but my b is negative. So turns out I have two negatives there. Negative of negative 6 plus or minus the square root of b squared. So negative 6 squared. Parentheses required here because when you're squaring the negative and the 6, okay? Minus 4, which is part of the formula. A is positive 6, C is negative 7. Again, watch your signs. Over 2 times A, which is 6. I continue. Negative of a negative 6 is 6, plus or minus the square root of negative 6 squared is negative 6 times negative 6, which is 36. Now check this out. Be careful here. Negative 4 times positive 6 times negative 7. Look, I've got two negatives in here. Two negatives multiply to be a positive, and then in my calculator, I'm just going to check out what that is. 4 times 6 we know is 24. And then times another 7 gives me 168. So what I have here is 36 plus 168 over 2 times 6 is 12. The process is you just continue to simplify this as much as possible. So 36 plus 168 gives me 204, okay, over 12. Now we need to break down 204. What I'm trying to figure out, is there a perfect square that divides evenly into 204? And I'm just playing with my calculator to figure that out. I know 4 goes in there. And 4 is the highest perfect square that divides it into 204. So how do I write this? 204 is 4 times 51. Now 51 does break down further, but not with a perfect square. 51 is 17 times 3. Neither one of those are perfect squares, so we are good so far. So I continue and get 6 plus or minus. Now I know the square root of 4 right here is 2, so that's going to come out. That's going to be 2 square root of 51 over 12. Now to wrap this thing up, here's what you got to notice. You're looking at the numbers not under square root, this 6 and this 2 and this 12. And my question to you, do they have any common factors? Well, yeah, sure, they all divide by 2. So that's what I'm going to do. I'm going to divide each of those highlighted numbers by 2. So that gives me x is equal to 6 divided by 2 is 3, plus or minus 2 divided by 2 is 1. Square root of 51, you do not divide it by 2. 12 divided by 2 is 6. Now, 1 times the square root of 51 is just square root of 51. So the best way to write this answer is x is equal to, now it's two different answers, right? It's the minus 1 and the plus 1. So 3 minus the square root of 51 over 6. And the other one is x equals 3 plus the square root of 51 over 6. And that is completely simplified. And for our last problem, we have a rectangular garden that is 10 feet longer than it is wide. They tell us the area is 3,000 feet squared. What are the dimensions? Okay, let's see what we can do here. So first of all, we have a rectangular garden. I encourage you, anytime you have some kind of geometric figure, to definitely draw a picture. So it says, you know, a rectangular garden, we have a length and a width. Let's use that. So we're going to say L is the length. So we're just going to call it L, and W is the width. We're going to call it W for now. But notice it says the rectangular garden is 10 feet longer than it is wide. Okay, so we know a little something about the length L is longer than it is wide in terms of W. So instead of calling the length L, you know what we could do? We could just call the length W plus 10. That would make our length 10 feet longer than it is wide, right? Okay. Then it's got this extra stuff that talks about the area. Now we know the area, formula-wise, of a rectangle is length times width, okay? And they tell us that's 3,000 feet squared, or 3,000 square feet. So 3,000 equals length times width. But look, we called the length, this L right here, we called it W plus 10. So here's what I'm going to do. I'm going to get rid of the L and replace it with W plus 10. So you have 3,000 is equal to, remove the L, use parentheses, replace it with W plus 10 times this W right here that's there already. Now what you have here is a quadratic equation. So I need to simplify the right-hand side by just distributing that W inside. So now I have 3,000 equals W squared plus 10W. My next issue is any quadratic equation that I need to solve, I need to get it equal to 0 unless I'm using the square root property. But look, not allowed to use the square root property because of this 10W. Whenever you have a variable to the first power, no square root property for you, okay? So I'm going to subtract 3,000, subtract 3,000. That gives me 0 on the left equals W squared plus 10W minus 3,000. Now we are where we were in the problem before last. Do we factor it or do we use the quadratic formula? Now, we do know the quadratic formula will work with every problem, but factoring doesn't. So you may want to jump straight to the quadratic formula, or you may want to spend a little bit of time and just see if this guy will factor. And you know what it does? If we try to find numbers that multiply to equal negative 3,000 and add to equal to the middle coefficient 10, what numbers do that? Positive 60, negative 50. Okay, so I'm going to factor. 0 equals W plus 60 times W minus 50. Now, how do you know if you factored it right? Hey, multiply it out. W times W is W squared. W times negative 50 is negative 50W. 60 times W is positive 60W. That would add to be 10W. And 60 times negative 50 is negative 3,000. What do you do next? You set each of these separately equal to 0. So W plus 60 equals 0 and W minus 50 equals 0. I subtract the 60 and I get W equals negative 60. And on the second one, I add 50 to both sides to get W equals 50. Now, you ever seen a rectangular garden with a width of negative 60? Nope, me either. It's some kind of imaginary place that we don't talk about, right? So the width is 50. When you're talking about distance or the length of a side, you can't have a negative distance. Okay, so W equals 50. Now, how do I find the length? Well, remember, look, the length right here, instead of calling it L, we called it W plus 10. So the length is W plus 10. So that would be 50 plus 10, which gives you 60. Now, I've done you wrong. Back here, remember, this is feet squared. So when you're talking about the length, I should put feet. It's not feet squared anymore because it's just a linear distance. It's only squared when you calculate area. So this would be length of 60 feet. I hope that brief rundown of several examples of quadratic equations and solving helps you out. Have a great day.